Oh, hi. Didn't see you there. Yeah, wow. Hello, Patriots. We're going to go ahead and go over the Algebra 1 Readiness Packet, page 1 today in a video. If you missed it or if you need to review, I will make a video for each of these pages individually as we work through the problems. Let's go ahead and get started. Our first review is going to be of the greatest common factor. Let's go ahead and jump right in, shall we? All right, so greatest common factor. Greatest means obviously biggest. Common means that these two numbers share. And factor is basically a number that we can divide divide the numbers by. So let's take a look. Greatest common factor, also known as the GCF of 12. So if we're talking about, so this is the kind of the long way to do it, and then I'll try and show you a quicker way to think about it. So basically the GCF, we have to list all the long way is to list all the factors of this number. 12 is divisible by 1. It's divisible by 2 because it ends in an even number. It's divisible by 3 because the sum of the digits are divisible by 3. It's divisible by 4 because you can divide it by 2 twice. It's not divisible by 5. It's divisible by 6. 6 is halfway to 12. So we can put 12. So it's a number will always be, divisible by 1 in itself. It's finding all the ones in between there that are hard. Let's do 18. 18 is divisible by 1, and it's divisible by itself. What are the numbers in between? It's even, so it's divisible by 2. Can it be divided into 3 groups? Well, yes. Divided by 3 would be 6, so that works. Not divisible by 4. Not divisible by 5 is divisible by 6. Not divisible by 7, not divisible by 8, is divisible by 9. 9 is halfway, so we jump to 18. Okay, so again, GCF is the biggest number that both of them, so biggest number that both of them share, that is a factor. So the largest factor that they both share is 6. So really, what we're looking for is we're looking for the biggest number we can divide both of these numbers by. Super. Let's go ahead and try the next group. So 6 is our GCF, or greatest common factor. Next one is 25 and 35. Okay, so this one's going to be pretty fast. Let's just look at the factors of 25. That's going to make things pretty easy. Factors of 25. We know that 25 is 5 times 5. So we know it's divisible by 1. We know it's divisible by 5 if 25 breaks up into 5 times 5. And there's going to be no other number that we can divide by other than 25. So our GCF then is the largest one of these we can divide 35 by. Well, we can divide 35 by 1. We can divide 35 by 5. We cannot divide 35 by 25, so 5 is our GCF. Let's look at the column. So that's going to be our answer. But if we look at 35, we can divide it by 1, not divisible by 2, not divisible by 3, because 3 plus 5 is 8, and 8 is not divisible by 3. It's not divisible by 4. It is divisible by 5. Remember, it's 5 times 7 is 35. That's its prime factorization. So we're going to have a 7 in there, and then combining these two, 35, there's our GCF. Okay, GCF of 12 and 18 is 6, 25 and 35 is 5. Let's go ahead and keep carousing. 13 and 20. Let's do that one. 13 and 20, let's think about that. Think about the smaller number maybe first. 13 is a prime number, so it's only divisible by 1 and 13, and we can't divide 20, don't write all these out, right? We can't divide 20 by 13, but we can divide it by 1, so 1 is our GCF, right? So this one's 1. Number 4 is, let's think about this, 40, 80, and 100. The largest number we can divide by 40, 80, and 100 by. We can divide 80 by 40, so that seems like a pretty good bet, but we can't divide 100 by 40. So let's go down to the next smallest factor of 40. So instead of starting at 1, let's start at 40 and work backwards. The next smallest factor of 40 is 20. We can divide 40 by 20, we can divide 80 by 20, and we can divide 100 by 20. So 20 is our GCF for number 4. Okay, next, let's cruise on. Find the least common multiple. Least common multiple. Okay, this one's a little different. Now, multiples and factors, that's the big difference here, right? A factor is a number that we can divide these two numbers by, or divide the numbers by. A multiple is when we take this number and we multiply it by 1, 2, 3, 4, 5. So the slow way to do these problems, 5 and 15, the slow way is to write the multiples of 5 out. Let's skip those underlines and let's just write 5 and 15. The multiples of 5 are 5, 10, 15, 20, 25, 30, 35, 40, 45, so on. There are an infinite number of multiples. For 15, it is 15, 30, 45, 60, so on and so forth. What the least common multiple is it is the smallest number that's in both lists, common, that they share. So the smallest number that the two lists share, that is a multiple. The smallest number that they share in both lists is 15. Okay, and the least common multiple is used for finding a common denominator when you are adding or subtracting two fractions. So we will, so basically when we get to that, that's where we're going to use this. The GCF is used for reducing fractions quickly to their simplest form. So that's the reason we're going over these two. All right, here we go. Let's start with 6 and 4. So multiples of 6, start with the bigger number. And basically the first one that you write that is also a multiple of 4 or is divisible by 4 will be your least common multiple. So 6, 12, 18. 12 is the first one that is divisible by 4. So I know that's going to be my least common multiple, but just for kicks and giggles, let's go ahead and write that out. 4, 8, 12, bingo. That's the first one that's in both lists. Okay, 8 and 9. Start with 9, and we're going to go up the list for 9 until we hit a number that's divisible by 8. So 9, not divisible by 8. 18, nope. 27, nope. 36, nope. 45, nope. 32 is divisible by 8, but not 36. 45 is not. 40 is. Okay, what else we got here? Next one, 54, nope. 63, nope. 72, yes. So 72 is our LCM. That's going to be 8 times 9. So I'm going to save some time here. So for number 7, the LCM, if you were to write all these out, would be 72. Okay, how about, you always start with the bigger number because then you'll write a multiple. So we're going to start with 25, right? We got 10, 15, and 25. Let's write the multiples of 25, and then the first one that we can divide by 15 and by 10 is going to be our LCM. So 25 we cannot divide by 15 or 10, so let's go up to the next one. 50, doubling 25, 25 times 2. I can divide it by 10, but I can't divide it by 15, so that's a problem. 75, I can divide by 15, but I can't divide by 10. Keep going. 100 I can divide by 10, but it's actually not divisible by 15. 125, 125, I'm not sure about that one. Let's see. It's not divisible by 10, so we can just move on. And then 105, I don't think it's divisible by 15 either. It's not. Okay. And 150 is the next one. 150 is divisible by 10 because it ends in a 0. And it is divisible by 15 because I know that it is 15 times 10. So our least common multiple is 150. So that way I don't have to write all three lists. Pick the bigger number, and then just work your way up until you find one that's divisible by the other numbers. All right. There's another way to find LCMs, but it's a little more, takes a little bit more time. I like it a lot, but this method works too. All right, simplifying fractions. So there are two ways that people were taught fraction simplification. So one thing you need to realize, what is simplifying a fraction? Fractions can have multiple forms. And what I mean by that is if you eat half a pizza, you ate one, so you cut it in two pieces, you've divided it into halves. If you eat 1/2, that is exactly the same amount of pizza. For example, if I were to cut it into sixths, and I ate 3 of those. If I eat 3/6, I cut it into 6 pieces and then eat 3 of them, I've eaten the exact same amount of pizza. This is just a simpler way to cut it for the same. I mean, it'd be really awkward to eat half a pizza at once, but it's a simpler way to express the number. Okay, so there are multiple ways, and it turns out there are an infinite number of ways to write 1/2 as a fraction. You can write it as 2/4. You can write it as 3/6, 4/8, but you can also write it as weird things like, how about 1.5 thirds? All of these represent 1/2. And if I go to a calculator and do 1 divided by 2, I get 0.5. 3 divided by 6, I get 0.5, so on and so forth. 1.5 divided by 3, 0.5 is the answer. So the two methods for fraction simplification that most people know, I'm going to show you the method that you were likely taught, and then I'll show you the method that I really like a lot. Okay. Most of you, would find the GCF of 12 and 15. So that's the largest number I can divide both 12 and 15 by. And that number is 3. So you can divide by 3 on the top, divide by 3 on the bottom. You'll get 4 over 15 divided by 3 is 5. So 4/5 cannot be simplified any further. You're done. Another way that I like to do fraction simplification, so you can use the GCF, but if you did 12/15, what you can do is you can kind of break each number apart into its prime factorization. So all the numbers that make up 12, that is to say, if I come down here and do 12 and break it apart, I can write it as 6 times 2, and 6 I can write as 2 times 3. So the prime factorization of 12 is 2 times 2 times 3, or 2 times 3 times 2, it doesn't matter. But it's 2 times 2 times 3. If I do the same thing for 15, it's 3 times 5. Now, anytime I take a number and divide it by itself, the answer is 1, and so what happens is these numbers cancel. 3 divided by 3 is 1, and so the numbers that are left over, I can't cancel anything else. The numbers that are left over are our answer. 2 times 2 is 4, and then there's a 5 on the bottom. Okay, I like this method a lot, dealing with primes. It makes a lot of sense to me. If you want to do the GCF way, you can, but this is a good way to think about numbers. Okay, let's do 20 over 28. We're doing, look at that. 20 over 28 is next. If you don't know the GCF, you can just keep dividing by numbers that you do know they're both divisible by. For example, I know they're both even, so I know I can divide by 2, even though 2 is not the GCF. You just have to be careful and check and make sure that your answer is simplified when you're done. Can I divide both of these by something else? Yes, you can divide them by 2 again. 10 divided by 2 is 5, 14 divided by 2 is 7. Can I divide these two by anything else? Nope. We're done. So check this out. We divided by 2 and we divided by 2 again. 2 times 2 is 4, so 4 was our GCF. 4 was the number that we could have selected to divide them by to begin with. Okay, let's keep rolling. I'm going to do the next one the same way. 8 over 56. 8 over 56, I can divide 8 and 56 by 8. So if you divide the top by 8, and you divide the bottom by 8, you'll get 8 divided by 8 is 1. 56 divided by 8 is 7. If you did this problem the other way, we get kind of a little interesting scenario there. For example, the way that I like to do these simplification problems, if you do 8 over 56 and you break that apart into 8 over 8 times 7, like that, a common mistake that people make is they go, oh, 8 divided by 8, well, what's left in the top? So people put a 0. You just have to remember that we can always write 1 times something. 1 times 8 is still 8. So there actually is a 1 left in the top there. Number 12, 48 over 52. For this one, do whichever method makes the most sense. I'm going to use my method, and I'll let you guys try it the other way. Feel free to pause the video at any time and try these problems if you have not yet on your own. 48 and 52, well, I know I can pull a 2 out of both of those. That would be 2 times 24. And down here, 52 is 2 times 26. Okay, let's keep going. I'm going to cancel those 2's. So now what can I do with 24 and 26? I can pull a 2 out and do 2 times 12. I can pull another 2 out, and that's 2 times 13. The 2's cancel, and 12 over 13 is our answer. Beautiful. 13 is a prime number, so I know I'm done. Can't break it apart any further. Almost done here. The last one says write each fraction as a decimal. For the scope of this course, I'm not going to worry too much about this, but this might be good to review. One thing you need to remember is that there are 3 kinds of decimals. If you do 1 divided by 4 into your calculator, you guys know that that is 0.25. But there are actually an infinite number of zeros that trail after here, right, that we don't write because there's really no point in writing them. So we call these kinds of decimals terminating decimals. Terminating decimals. But if you look at a fraction like 1/3, if you're to do the division with this kind of a problem, you end up, if you plug this into your calculator says 0.333 and it takes up your whole screen. These 3's never end. They go on forever. And so we call this a repeating decimal. So if any decimal that terminates, or that means ends, or any decimal that repeats is what's called a rational number. Okay? It means there is a ratio that you can express it as. All right. Now, there are also decimals that never terminate, kind of like this, and they also never repeat. And those kind of decimals are numbers like pi. These are rational numbers. And pi is what's called an irrational, or a non-rational number. So irrational is what we call that. That's 3.141592653, whatever. Okay, it goes on. There is no repeating pattern, and it's never going to terminate. So this is an irrational number. So these are the kinds of decimals that you can run into. How do I write the fraction as a decimal? Well, for this course, I'm not going to make you guys do much long division, but it might be a good refresher for us. 7/10 should be pretty basic. Your decimal places, like let's say 3, 7, 8, 9, 5, 4, 1. This is the ones place, right? Let's do a 4 here. This is the ones place, this is the tens place, this is tens, and then let's say this is a 6 up here, this is hundreds. Okay, so it's 640 right here, and then we have this long trailing decimal. This is kind of like the mirror line. So here's tens place, this is tens, this is ones, this is tenths, hundredths, thousandths, 10,000ths, 100,000ths, so on and so forth. So if you see a fraction like 7/10, we have 7 of these tenths, so you can just write that as 0.7. You can also go to your calculator and do 7 divided by 10 to write it as a decimal. Now 3 divided by 5, we can write that as an equivalent fraction as something over 10. Okay, if I turn 5 into 10, that means I multiplied it by 2, so we multiply the top by 2 to do the same thing. It'll be 6, which means we can write that as 0.6. Uh-oh. 13 over 20. Ooh, that's crazy. Yeah, so again, for fractions like this, you can, I don't think it's reasonable if you have a phone in front of you to do the long division or do anything crazy. This one, there actually, I think, is a fairly easy method for us to use, and I'll kind of show you that. This one's a little weird, but 13 over 20. Now, this is maybe a little kind of a funky trick, but I can write this as tenths. If I take 20 and I divide it by 2 and turn that into 10, I can do the same thing up here. But 13 divided by 2 isn't, it's a decimal. It ends up being 6.5, okay? 13 divided by 2 is 6.5. So how do I write 6.5 tenths? Well, you just really, when you're dividing by 10, it's really the same thing as kind of moving the decimal place over. Currently, the decimal place on the 7 is right here. Dividing by 10 moves it over one place. If the decimal place is here on the 6, dividing by 10 moves it over one place. So you're just moving it over one place to the left, which means 0.65. Cool. Okay, the last one. I think I bit off more than I can chew here. You're going to watch me do long division here. 7 divided by 15. So it's helpful to know the multiples of 15 when you're doing long division to write this as a fraction. Again, if you want to watch the long division, feel free to stick around, but not super important, I think, for this course. 15, 30, 45, 60. Let's see here. 75, 90, 105, so that's 1, 2, 3, 4, 5, 6, 7. 8 is 120, 135, and 150 is 10. Okay, so let's do, if we're trying to write 7 fifteenths as a decimal, 15 fifteenths would be 1. So 7 fifteenths has to be less than 1. It's going to be a number, it's got to be a number less than 1. It's going to be some decimal, right? It's almost, 7 is almost half of 15. It's close. Half of 15, I think, or is 7.5, so it's close. So it should be, our answer should be something close to a half, or 0.5 when we do the division. So what we do is we put 7, the thing that we're dividing, that's our dividend, and then we have the quotient as our answer, and our divisor is 15, the thing we're dividing. Okay, so the decimal place is right here. So the decimal place in our answer goes up there. I can't do 15 divided by 7, so I put a 0, and I add a 0 here. 70 divided by 15. What's the largest multiple of 15 that we can subtract from 70? That's going to be 15 times 4. Okay, well, I said it's close to 0.5, right? 4 times 15 is 60. We can subtract, bring down the 1, 0. Now I can't do 10 divided by 15, so I have to add another 0 and bring that down. How about 15 or 100 divided by 15? Well, then let's 1, 2, 3, 4, 5, 6 is the closest multiple. 6 times 15 is, there's my 90. And look what happens here when we subtract. We bring down 10, bring down another 0, and we can stop right there because we brought this 0 down right here. We got the answer 10 and we brought that 0 down, and we're about to bring it down another 0 onto the 10. So that means this 6 is going to happen over and over again. So the decimal answer for 7 divided by 15 is 0.46. Long division. Whoa, super fun. All right, that's it for page 1. I'm going to have a page 4, or a video for each of these pages. So thanks for watching. More videos to come.